In this video, we're going to discuss the constants that are available in Python's math module. That's pi, tau, e, infinity, positive and negative, and not a number. And if you're not sure what that means, don't worry, we will explain it. First things first, though, we will need the math module. The good news is you don't need to download anything. Python's math module is built in, so if you want to use it, you just have to type import math. And there you have it. The math module comes with these constants I list above. I'll start with one that should be familiar, and that is pi. Pi has endless digits. Somewhere out there, there's computers churning away, calculating more and more and more digits of pi. We don't want that to be our computer. Our program would never do anything else. There's a host of other limitations involved. This is just going to give you an approximation of pi to a certain number of digits like you would get on any calculator. Let's take a look. To get the approximation of pi in the math module, well, first let's type math, and that indicates you want to use the math module. Then you type dot, and that dot indicates you want to use a function within the math module. Then you type out the name of the function you want to use, in this case, pi. So you type math.pi, and let's try printing that to see what it gives us. And indeed, it gives you 3.14 and change, gives you pi within 15 digits. You can also set it as a variable. And you see what I did there is I just put pi equals math.pi, because math.pi, it's a constant. And then to show you what happens when you print pi, the variable that I just made, it gives you the same thing. And that's really nice if you are going to be typing using pi a lot. You don't have to type math.pi, math.pi, math.pi. You can just type pi. So that could be handy depending on what you're doing. Now, what kind of a value is math.pi? Well, it's a float value. So to see that, let's just print out the type. So you have the type. You're asking the computer what's the type of math.pi, and then you're printing whatever it comes back with. And you see it is a float value. Let's do an example to see this in action. You might remember that the circumference of a circle equals pi times the diameter. In my math class, the teacher actually pointed to a guy named Craig and said, you can remember the circumference through Craig has to go pi d. And that's a pretty mean thing to do to some 7th grader named Craig, but I do still remember it that way. In fairness to her, I remember it as Craig has to go pi d, or c equals pi times diameter. Anyway, let's set up a little formula here. We'll need a diameter, and let's just make it 3. And we'll need pi. Let's make it math.pi. And then we'll have c equals math.pi. And then we'll print c. Well, what are we doing here? Well, we're importing math, so we're telling the computer, hey, we want to use the math module. And then we're setting a variable called d to be the value 3. And then we're setting a variable called pi to be the value, the float value we just saw, math.pi. And then circumference equals pi times diameter. C equals pi times d. And so then what we're going to do is we're going to print c. It's going to do all the calculations, store the value, store this value times that value within the value c, and then print c. So it's going to print the circumference of our circle that has a diameter of 3, and it does. And so as you'll see, our circle has a circumference of 9.4 and change. Okay. Well, that's just one quick example. You can imagine any number of things you can do with this, pretty much anywhere that you want to plug in pi. You could either set a variable called pi to math.pi, or just type math.pi. The next one that I want to discuss is called tau. Tau, T-A-U. And what in the world is tau? Well, it is a constant that has the value of 2 times pi. So tau equals 2 times pi. There's a big contingent of people that prefer to use tau over pi. The practical argument generally goes that a lot of equations call for 2 times pi, so why not make 2 times pi its own constant instead of having to write 2 pi all the time? If you're interested in the more theoretical argument that has to do with radians, there's a lot of literature out there, but this video isn't really about whether you should be using tau or whether you should be using pi, because the good news is that the Python math module offers you both. So it's entirely up to you which one you want to use. The other good news is that if you know how to use pi in Python, in the math module that is, then you know how to use tau in the Python math module because it's used in the same exact way. We have math imported, and we type math to show that we're using the math module. Then we type dot to show that we're going to use a function within that math module, and then tau, T-A-U. And then we have it. So let's print it and see what we come up with. Print math.tau. Let's run that. And there it is, 6.28 and change. And in fact, Tau Day is June 28th. And on Tau Day, you can eat twice as much pi. So just like pi, tau is a number that can go on and on forever. It's literally just pi doubled. Python math module gives you 15 digits after the decimal, just like with pi. Now, is tau in the math module truly 2 times pi? Well, let's take a look. Let's make a variable, and we'll call it double pi. And let's set that to equal 2 times what we know to be math.pi. And let's make another variable and call it tau. And we'll just set it to math.tau. So right now we have double pi, which is 2 times math.pi, and we have tau, which is math.tau. There's a couple of things we can do to try to test this out. One is we can just print both of these. So let's print double pi, and let's print tau, and let's run it and see if they come back with the same thing, and they do. Another thing we can do is we can make a little if statement. Let's do if double pi is equal to tau. Okay, then what do you want to happen if double pi is equal to tau? Let's have it print, yippee, tau is twice pi. Okay, but if it's not double pi, so we'll do that with an else, then print, you're wrong. Tau is definitely not twice pi. And hopefully we'll get a yippee out of here. Let's see what happens. Yippee! Tau is twice pi. So for good measure, let's go ahead and put tau in action as well. You might remember that we just discussed how the circumference of a circle is pi times the diameter, and that's how I learned it. Craig has to go pi d. Well, what's the diameter? It's 2 times the radius. Some of you might have learned circumference is 2 pi r. That is c equals 2 times pi times the radius. Well, we don't need to say 2 times pi because we know that it's actually tau times the radius, right? Because 2 times pi is the same thing as tau. So let's make a formula. We can say that c equals math.tau times radius. Okay, well that's wonderful, but we'll need a value for the radius. And let's use the same circle we used before that had a diameter of 3. Now let's say it has a radius of 1.5. So let's try it. We have radius is 1.5, circumference is math.tau, so it's tau times the radius, and let's print the circumference. What's this doing? This is telling us we're going to use the math module. We have a radius of 1.5. We have the circumference, which is tau as it's used in the math module, times the radius. Okay, so it stores the value of our circumference in this variable c. Print out that variable c. What does it say? Well, it says our circumference, which is the same value as we had before for the circle with the diameter, excuse me, of 3. Now it has a radius of 1.5, same circle. The another constant that the math module gives you is E. E is Euler's number. It's an irrational number like pi or tau. It goes on and on forever. It doesn't repeat digits, and just like tau and pi, you do not want your computer to be calculating E forever. That would really not let you do anything else. It would just continue to calculate E. So, just like with pi, just like with tau, the math module gives you an estimation. Let's see what happens. Now, as before, you have your math module imported, and the E, it's math.e. Pretty similar to the pi and the tau, and let's go ahead and print that. So if we print math.e, what does it give us? It gives us E, which is 2.71 and change. Or as before, you could always make it into a variable, of course. Depending on what you're doing, you could make E equals math.e and then just print E. And it gives you the same thing. And it gives it to you as with tau and as with pi, it gives it to you within 15 digits. E is pretty useful. There's a lot of different times it comes up. A classic example where E is used in math would be if you take a new deck of cards, it's unshuffled, brand new deck of cards, ace, 2, 3, 4 of spades, etc. It goes on and on. It's completely unshuffled. Then you shuffle the deck of cards and shuffle it well. I know that sometimes you need to shuffle a few times, but if you shuffle the deck of cards properly, it's been proven that the probability that none of the cards are going to be back in their original slot that they were the first time is 1 over E. And so that's just one of the many, many equations where E pops up. It's all over math, but just for purposes of showing math.e in action, let's use that as our example. So what we have is we have the odds of the cards not going back into the same place after they're shuffled equals 1 over E. So let's see. So what we'll do is, why don't we have a variable called odds, and we'll make that 1 over E. And instead of, and we have, as you recall, we already set a variable, E equals math.e. You could also just do 1 over math.e, which might be easier to follow. And then let's print the odds. And so that's 0.36 and change. So in other words, about 36.7879, etc. percent. If you want to make that more of a percentage, you can always multiply it by 100, and you'll see now you're getting it as 36.7, etc. percent. So there you have it, the odds that if you take a fresh deck of cards and shuffle it, no card is going to be back in the same place, using math.e from the Python math module. Next up, we're going to discuss infinity. The math module comes with a means to represent infinity as a float value. Well, it's not actually calculating infinity, that would be impossible, but if you want to represent infinity in math, you can do the following. You do math for the math module, dot to say you want to do a function in the math module, and then inf, short for infinity. And so let's see what happens when we print that. Okay, so it prints you inf, inf. Well, you're thinking, inf, big deal. I can just, I can just do this. I can just print inf. And hey, it's the same thing. I got inf. Well, you're on the right track in some ways, but the infinity in the math module is not the same as just a string inf. And to show that, we can check the type. And let's actually print type math.inf. And what we will see is that it's actually a float value and not a string, versus if we were just doing the previous example where it's INF, well, that is a string. And so it's a different type of value, but maybe it's not so different. Let's see. One thing we can do uh, during using the math module is we can check whether something or not is infinite. So let's do that. That is math dot is inf, and let's just do this with infinity. So what is this doing? This is math to the math module, dot to show, hey, I'm going to use the math module for a function, is inf is our function. This is asking, is it infinity? And then math.inf is, as you'll recall, the float value that gives you the INF. Well, is this an infinite value? Well, of course, that didn't do anything because we'll need to print it. Is this an infinite value? Yes, true. Okay, but then what happens if we just do our friend the string INF? Well, this will be interesting. It's an error, and that's because it says, hey, this must be a real number, not a string, you fool. Okay, well, well, okay, fine. Say, okay, fine. But I'm going to convert it to a float. So why don't I do, let's make our string inf into a float by making it float. Inf float inf, and it's true. It's true if you convert the float of just the word inf, if you convert that string into a float and then you say, hey, is it infinite? Then it prints back a variable true that is infinite. Well, what's going on here? Math.inf is actually the same thing as the float of inf. Well, don't take my word for it. Let's see if we can prove it in a couple of ways. Well, let's try making another if then statement. So if math.inf is equal to float of inf, then let's print, holy moly, they are the same. Let's get rid of that extra f. Else, let's print, nope, not the same. Frowny face. Okay, so let's see what happens. Ah, holy moly, they are the same. Let's clear the console and try it again. Holy moly, they are the same. Okay, so while we're on the subject of infinity, you can also do negative infinity. And you just do that by doing negative math.inf. So let's start again. And as you see, it's negative math.inf. And that gives you negative infinity. So let's try printing that. Print negative math.inf. Let's clear this out. And there it is, negative inf. And is that the same, you might be wondering, as saying float INF? Because you see it's negative INF. Is that the same as saying float negative infinity, like this? Well, let's find out. If float of negative infinity is equal to float, oh no, I'm sorry. Is negative float negative infinity can be equal to float negative infinity? Is float negative infinity going to be equal to negative math dot inf? Well, if float of negative inf equals negative math dot inf, print hooray, they are equal. And it's important to always be grammatically correct when saying hooray, they are equal. Okay, else print those two aren't equal. What are you trying to pull? Okay, let's find out what happens. Hooray! They're equal. Okay, great. And does the math module consider this to be an infinite value? Well, let's try the isInf function. So let's print math. Okay, see it lights up math dot isInf. And let's try negative math dot inf, negative infinity. And let's see if it's true. And it is. It is true. And so negative infinity is also considered to be an infinite value. So you could do positive or negative infinity. Well, what are some things we can do with infinity? Let's open up the console and let's play around with this a little bit. And I'll make this a little bigger. So we'll import math. And then let's do math dot infinity plus 4. And what do we think is going to happen when you add 4 to infinity? It's still infinity. Infinity plus 4 is just infinity. Okay, well, what about math dot infinity times 3? And that is still infinity. You multiply infinity by 3 times, that's infinity. Well, let's try a more tricky one. What if we subtract infinity from infinity? Math dot infinity minus math dot infinity. You might think, oh, 0, right? X minus x equals 0. Math dot infinity minus math dot infinity, and that should be 0. Well, let's find out. NaN. It is not a number. Well, infinity, it stretches out forever. Perhaps you can't really subtract infinity from infinity. And it gives you this interesting value, NaN, which stands for not a number. What in the world does that mean? Well, the good news is we're going to be talking about it right now. Sometimes you might want a float value that's not a number. And, well, maybe you think, well, I just did the float of INF. Maybe we could do that with just anything. So, as you saw, we just did print float INF, well, and that printed something, so what if I did print float of hi? Is that going to give me a float value with hi? No, it gives you an error. It says value error could not convert string to float hi. So you can't do this with everything. There's actually only a couple of things where you can type in letters like that and convert it to a float. And one thing you can do is you can do a float of NaN, and that is not a number. NaN, and it gives you NaN, and that's NaN as a float value, and just like with infinity, but you can also use our math module that we have imported here and aren't even using. So how do we do that? Well, it's math.nan, and that gives you the float value of not a number as well. So let's just show you that in action. Print math.non, and it gives you not a number. And so it gives you that float value, nan, not a number. So let's check its type. Print the type of math.nan, or nan, people call it different things. And it is a float class, and is float nan equal to math.nan? Well, let's find out if float nan, because remember we did this with infinity, where float of infinity was the same as math.infinity. Is it going to be the same for not a number? Let's find out if the float of not a number is the same as the math to not a number. Let's find out. So let's do if float of not a number is equal to math dot not a number, print yes, these two are equal values. Hooray, hooray. Else print nope, Those are not equal values. Not at all. Well, what do you think is going to happen? You might think because the it worked for inf, maybe it worked for for nan. Nope, those are not equal values, not at all. Well, why in the world not? Well, the answer, interestingly enough, is that nan does not equal itself. It's not a number. It doesn't equal anything. It doesn't even equal itself. So if I did the same thing just with math.nan, these are literally two things. If math.nan is equal to math.nan, print, yes or no. No, it's not an equal value. So I will represent to you that float of nan is if math.nan and float.nan are different means of expressing the same value, but they're not going to show up as being equal to each other because nan does not equal nan to begin with. All right, let's see this in action. Let's say that we have a variable called math.nan times 6. So the variable is just called var, and it equals not a number times 6. And when we print that out, what do you think is going to happen when we multiply something that's not a number times 6? It is itself not a number. It's not a number either. Not a number times 6 is also just not a number. Well, does that mean anytime you ever throw nan in the mix, it will always return with not a number? Well, let's see. Let's change our formula here and try not a number math.nan times 0. Well, as you probably know, anything times 0 is going to be 0, so even if it's not a number, I mean, if you multiply it 0 times, maybe it'll be 0. Let's see. No, it's not a number either. Well, you've probably heard that anything to the power of 0 gives you 1. Well, what if we do math.nan, and then when you do to the power of, that's actually 2 asterisks, star star, to the power of 0. So math.nan to the power of 0. What's this going to give you? Now you're probably sitting there thinking, oh, I know, it's going to give me not a number. If times 0 is not a number, then raised to the power of 0, anytime you throw it in, it's going to be not a number, right? Well, let's see. No, it gives you 1. And one more example, 1 to the power of math.nan. 1 to the power of not a number gives you 1. Well, why do these two exponent work? Why do these two exponents work, but multiplying by nan by 0 doesn't? I didn't know. I did some Googling, and from what I can tell, it's just a byproduct of historical conventions in computing that were carried over into Python. But if you have a better explanation, leave a comment and let us all know. Because as far as I can tell, there's no particular reason aside from that's how it's always been. So last thing, and there's one more issue with nan, and this one is probably easiest just to show you from the console, so let's do that. Let's actually just make a new console. I know I've got a lot of consoles up, so let's clear these out. Okay, and so here's an issue with nan. You might be able to just check to see if something is true or not in math, just with the console here. So say you wanted to know, hey, 4 equals 2 plus 2. So 4 is equal to 2 plus 2. Is that a true statement? If you hit enter and it's a true statement, it'll say true. If it's a false statement, it'll say false. Something you can do with the console. Okay, well, it's true. 4 does equal 2 plus 2. That's true. Okay. What about 4 is equal to 2 plus 3? No, that's false. Okay. Sure, we're on the same page here. 4 is equal to 2 plus 2. 4 is not equal to 2 plus 3. That's false. Okay. Well, let's import math into the console. And let's do math.nan is equal to math.nan. And do you have a guess as to whether this is going to show up as true or false? It's false because not a number doesn't equal anything. not even another, not a number. And so those don't equal each other. It's false. Well, that can present some issues because what if we were curious about if math.nan is equal to math.nan times 6? Well, what's this asking? You might think this is asking is math.nan is not a number times 6 also not a number? You, that would be a reasonable way to look at this expression and think that's what it's asking. But it presents you with false when we just saw a few minutes ago that when you do an operation with not a number, it is not a number. So it should be returning not a number. So what's going on here? Well, it's just saying this value that does not equal this value times 6, it doesn't equal. It's just not on the same side. So how do you check whether a figure is not a number or not? If you can't do that, well, what you can do is there's a different function in math called math dot is nan, and that asks the question, hey, is this a nan value or isn't it? And there, when we do math dot nan times 6, which is the same thing we did up here, that time it's true. And so let's compare that to the other value we just saw where we did uh, math dot is nan, math dot nan to the power of 0, which remember gives you a numerical value that's not a number value. So math dot is nan. So this is asking the question, hey, is this a nan value? False. No, it's not a nan value. That gives you a regular value. And so that should conclude the video for today. These are the different constants that you can use in the math module in Python. Thanks very much for watching.